Welcome to this explainer. Today, we're diving straight into a totally fascinating intersection of ancient history and cutting-edge artificial intelligence. We're going to look at how modern machine learning is actively unlocking the acoustic secrets of humanity's oldest unbroken oral tradition. This is really a story about memory, sound, and how tech can help us hear the invisible layers of our own cultural heritage.
Section 1. An ancient oral tradition.
Imagine traveling back over 3,500 years to the origins of the Hindu Vedas. Long before we had hard drives, cloud storage, or even widespread written language, human memory was literally the ultimate storage medium. Brahmin priests dedicated their entire lives to preserving this massive corpus of poetry, philosophy, myth, and ritual incantations, and they did it all entirely without writing. It's just a staggering feat of human cognition, relying purely on oral transmission from teacher to student across thousands of years.
UNESCO actually recognizes this incredible preservation as a masterpiece of the oral and intangible heritage of humanity. But you've got to wonder, right? How did they do it without the message getting totally garbled over time, like a giant game of telephone? Well, they used incredibly intense, structurally redundant methods. They didn't just memorize sentences. They used techniques like repeating syllables 6 times, both forwards and backwards in these intricate permutations. Basically, if even a single syllable was out of place, the whole rhythm would break, and they'd immediately spot the error.
Section 2. Digitizing the Vedas. Now, there's a massive time crunch here. Out of the original 1,000-plus Vedic recitation branches that existed, only 13 survive today. We are literally at risk of losing an irreplaceable piece of human history. So, to preserve this fading heritage, researchers at IIT Kharagpur created the Vedavani dataset. It's this incredibly urgent, first-of-its-kind archive containing over 54 hours of audio, completely broken down into 30,779 meticulously labeled audio samples from both the Rig Veda and the Atharva Veda. When you look at the raw data, mapping the duration of these audio clips against the characters per sentence, you can visually see the cadence of an ancient oral tradition turning into modern data. The chants naturally cluster around a specific breath length, usually about 5 to 10 seconds, and a specific character density. It's just this beautiful translation of human breath and rhythm into quantifiable blocks of data.
Section 3. Beyond Text. Acoustic Analysis. So here's the real scientific mystery. We know the words of these Vedas have survived intact for 3 millennia, but what about the actual sound? Have the specific vocal techniques, the harmonic structures, and the acoustic fidelity perfectly survived, or have they drifted over time? To figure that out, researchers brought in a framework called VSD, or Virtual Spectral Decomposition. I know it sounds super technical, but just think of it like a highly advanced audio prism. Just like a glass prism splits white light into a rainbow, VSD splits complex audio signals into specific frequency bands. This lets researchers pull out incredibly granular features, things like peak energy and spectral flatness, that our human ears might completely miss.
And just to be clear, this tech isn't just theoretical speculation. VSD is incredibly robust. It can catch industrial steel defects with over 99% accuracy, and it classifies the biological calls of elephants at over 90%. And now, it's hitting a .962 score on human speech, specifically Vedic Sanskrit. So it's a rigorously proven analytical tool.
Section 4. The Ultimate Confound Test.
When researchers first applied VSD to classify the audio of the Rig Veda against the Atharva Veda, it scored a perfect 1.000 AUC. It separated the two traditions completely flawlessly. But look, in data science, a perfect score immediately sets off your detective instincts, right? It almost feels too good to be true. You have to ask the critical question, was the AI actually hearing ancient vocal techniques, or was it just detecting different room acoustics? Like, did it just notice that the Rig Veda was recorded on a different microphone than the Atharva Veda? Because if the AI is just memorizing recording fingerprints, the whole study falls apart.
To settle that exact doubt, researchers ran the strictest possible validation test. They trained the AI on 50 specific recording sources and then tested it on 24 totally different ones. Literally, zero overlap in microphones or room conditions. And guess what? The high score held incredibly strong at .962. This definitively proves that the AI isn't just listening to microphone static. The acoustic difference between these ancient traditions is 100% genuine.
Section 5. Discovering the acoustic signature. Okay, so if the difference is real, what actually is the acoustic signature that separates these 3,500-year-old traditions? How do they fundamentally sound different to a machine?
Well, once they mathematically stripped away all the room noise and recording artifacts, the defining feature completely shifted. It wasn't about absolute energy anymore, meaning it wasn't just that one group was louder or singing at a different pitch. The key separator became harmonic complexity. This means the two traditions use fundamentally distinct vocal production techniques. It's literally in the density of the vocal resonances, the physical way the reciters are using their throat and nasal cavities, that completely separates the lineages.
The results here are just wild. If you try to tell these two Vedas apart using only their written text, the model scores a 0.665. But if you use just the acoustic VSD data, a perfect 1.000. That massive gap of 0.335 is monumental. It proves there is a vast wealth of cultural and historical information baked directly into the vocal tradition itself, information that becomes completely invisible if you're only looking at the written text. The medium truly is the message here.
Section 6. Preserving the future.
So why does all this highly technical acoustic analysis actually matter for you and for the preservation of human heritage? Because this breakthrough hands us three incredibly powerful tools. First, it opens the door for a mobile recitation training tool, where students can actually get objective, quantitative feedback on their chanting. Second, it serves as a heritage monitor. We can mathematically track those 13 surviving branches to guarantee they don't acoustically drift over the coming decades. And third, we can take this exact same spectral framework and deploy it to preserve other fragile oral traditions around the world, from Gregorian chants to Tibetan Buddhist recitations.
I want to leave you with this provocative thought today. We spend so much energy digitizing texts and analyzing the written word. But as we digitize our entire world, what other ancient, completely invisible cultural secrets are just waiting to be decoded from the very sounds of our past? Thanks for joining me on this explainer, and remember to keep questioning what you hear.